I'm Tom Scherer. I'm an extension agricultural engineer with North Dakota State University, and today we're going to be talking about sump pumps, sump pump installations, and why they're needed. The primary reason that sump pumps are important is that they are the first line of defense to keep water out of your basement, protect your possessions, also protect the foundation and the structural integrity of your house. And so there's some steps you have to go through to make sure that your sump pump is running correctly and ready to take on, because in the early spring when we have a lot of snow melt, or in the summer when we have heavy rains, your sump pump is going to be running, and it may not have run for a while last fall or even a year ago. And so we need to check it annually just to make sure that it's running properly, it's in good shape. Behind me is a kind of a typical sump pump installation here in North Dakota. There's a cover over the top, and then this homeowner has put a plastic over it. And there's a couple of reasons for that. First is safety. It's a safety concern to keep children and pets out of there, plus also debris that may be in the basement that could fall in and plug the pump. Second thing, in this case, the plastic is to reduce the evaporation and smells that might come into this finished basement. And also in this part of the country, radon is a concern in basements, and a sump pit is a good place for radon to enter. So what we want to do then is check your sump pump. And before I do take the cover off, I want to point out some features. First, you notice a sump pump is driven electrically, and because it's in water, if you're working with it, you want to make sure that that circuit is protected with a ground fault interrupter, or GFI, somewhere on the circuit, so that if you're handling it, or if there's a shock, it doesn't kill you. It trips the breaker on the GFI. Second thing is, this is the discharge pipe. As you can see, if I remove the cover, this is the discharge pipe going up, lifting the water up, and it's going to go out through the rim joist and exit the house straight out to the side. Now outside, the homeowners probably has a pipe on it that directs the water away from the house so that it drains away from the house, even in the highest water situations. This is the sump, and of course that's the pump, and they call them sump pumps, but they sit in a sump, which is just a term for holding water. And as you can see right here, this is the drain tile where the water comes in from the footing drains from the outside of the house and pours into here. This part of the discharge piping is the check valve. And what a check valve does is only allows water to move one direction. In this case, it would move up the pipe. And there's a flap inside there. And so if water tries to flow back again, it holds it in the pipe. And that's important because you don't want the water that's trapped in your discharge pipe to flow back into the sump. It just adds to the amount of water flowing in and makes your pump run more frequently. You can also notice there's a very small amount of sediment there, but there's no other debris in there. If for some reason your sump pump has debris, floating lint or other material, you probably should clean that out first before you test your pump. In this case, we have a dry hole. This pump hasn't run for a while, so we're going to put some water in it just to make sure that it's running properly. In this case, we have a garden hose, and we're going to run the water in there very slowly so we can observe the operation of the pump and the float, and to make sure that it's in working condition. You can also, if you don't have a hose available, you can use a 5-gallon pail of water and just pour the water in very slowly. So then we'll just slide this to the bottom and slowly add water to it. If you watch the operation float, you want it to be nice and smooth. You can see it moving, and as the water level comes up, it'll push the float up and turn the pump on. When the pump comes on, you want to listen to it very carefully. One of the main features of these pumps is that the switch is kind of the weak point of them. And so you want to make sure that when that switch trips, it trips and stays on. There's no hesitation. And then you want to listen to the operation of the pump. Make sure there's no squealing or any other noise to indicate that probably the bushings are not in proper working condition. This pump makes a nice smooth sound. There's no squealing or anything. Indicates it's in good working condition. But if it does make any unusual sounds, then you probably want to have a replacement pump on hand in the basement so you can be replaced very quickly. If you're going to check it this way, you'd like to do it twice just to make sure that everything runs properly and that it dewaters the sump as it's supposed to. And then we'll listen to it shut off to make sure that when it pumps it down, and you can hear that the check valve is also working. So you heard the check valve click. That means it's holding the water in the pipe and that's not flowing back into the sump. Another type of sump and pump operation is what we call seepage sumps. And we have one right here, and these can be almost any diameter, anywhere from, in this case, this is about a foot diameter, but they can be up to 18 inches diameter. And this one has a small amount of water at the bottom, and you can see some materials have fallen in here. If enough of that got in, it could pose a problem for getting sucked into the pump and preventing the pump from doing its job. But as you look real close, you'll see that there's no outside inlet. The only way water can get in is through these small holes here. It's not connected to any footing drains, and that's why we call it a seepage sump. In this case, we have a small diameter sump that's pretty deep, and so we have a small diameter pump. You can see the inlet where the water comes in, but most importantly, because it's a small diameter, this tethered on switch has a long travel distance. So when the pump does turn on, the water has to come up, as you can see, probably over a foot before it turns on. And so the pump runs for quite a while, which is good because the flow in is going to, in a seepage sump, the flow is going to be much slower than in a standard sump where you're connected to some kind of an outside drainage system. When you have to buy a new sump pump or replace one, and you go to the hardware store, sometimes it can be very daunting to come to the display and see a wide variety of pumps with different connections and so forth. And we're going to show you some different types of pumps and explain some reasons why you might select one type over another, and look at the different connections to them and how they work, and hopefully give you a better idea when you go to the hardware store how to buy a replacement pump. Now, in front of me right here, you can see that we've got some pumps set up. First, I want to point out this is called a pedestal pump. It actually sits on a pedestal. It has the impeller, or the part in the pump that actually moves the water, is located down here. The inlets are here, and the discharge would come out here and rise up in the pipe. And then we have submersible pumps. And again, as the name implies, they are designed to be submerged in water. These are sealed pumps. Electric motors here. You can see very similar, same type of impeller here. In the intake, the water flows in through these screens right here. And these are fairly small openings, so they can get plugged if there's a lot of lint or other small floating material in the water. Same as these types. They're all very similar. What sets them apart is the float mechanism that turns the pump on and off. In this case, you can see it very clearly that the float is here. This would sit down in the water, and as the water rose, it would turn the pump on. Now you can see that this has about 10 inches of rise to it, and you could adjust it higher if you want to. That's a very desirable feature in some sumps because then it pumps out a lot more water. And as you can see, it drops down and shuts off again. On the submersible pumps, this type has a diaphragm switch, and the diaphragm's underneath here, and when the water level's here, it shuts off, and when the water level rises up to about right here, it would turn on. As you can see, that one has about 8 inches of travel, and there's no adjustment to it. This one has the float attached, just like the pedestal pump has a float on the outside, and it rises up, turns on the pump, and as it goes back down, you can hear it shuts off the pump. You can see that this has about 4 inches of travel. And then the last main type is a tethered switch. which is tethered right here. And as this float rises up, it turns on. And then as the water level recedes, when it gets down there, it shuts off. So it's about twice this distance, or about 8 inches. You can actually loosen this and pull it out so that you can increase the amount of travel, so that now the water level that you're pumping out becomes equivalent to the pedestal pump. The other thing that a lot of people are concerned about is the horsepower rating. How do you go about selecting what horsepower pump? If I turn these around, we have 3 different size pumps here. This is a 1/3 horsepower, this is a 1 horsepower, this is a 1/2 horsepower. If you only have to move the water 20 feet away from the house, then a 1/3 horsepower pump will probably work just fine to move the amount of water you need out of a standard house. But if you have to add on more length, or you have to move that water farther away in a hose or a pipe, then there's going to be more resistance to flow, and you're going to have to go to a higher horsepower. If, for instance, if you have to pump that water 60 feet or more from the house, you might want to look at a 1/2 horsepower pump, or a 3/4, and even a 1 horsepower pump. The important point to remember here is that before you go to the hardware store, look at your pump that you're replacing and look at the horsepower rating on it. And if you were satisfied with the operation of that pump and that it moved the water away, then replace it with that horsepower rating. Not much is going to change beyond that.